NASA's Voyager 1 spacecraft, which presently holds the distinction of being the most distant human-made object from Earth, has captivated individuals worldwide for nearly 5 decades. Since its launch, Voyager 1 has transmitted crucial data from the periphery of deep space, expanding humanity's comprehension of the cosmos. Nevertheless, the probe's recent communications have exhibited atypical irregularities that have left researchers bewildered. These enigmatic signals have sparked intense debates, raising inquiries about whether these are merely technical glitches or indications of something far more extraordinary, possibly even extraterrestrial activity. Join us as we delve into these mysterious messages and contemplate what might be concealed within the vast expanses of space. The inherent human urge to unravel enigmas has long propelled our quest to explore the universe. This profound curiosity laid the foundation for bold missions like Pioneer 10 and Pioneer 11, which were among the most ambitious space projects of their time. Voyager 2 launched from NASA's Kennedy Space Center on August 20, 1977, marking the commencement of a transformative era in space exploration. Shortly thereafter, on September 5, 1977, Voyager 1 was launched, initiating a journey that would carry it past the outer planets and significantly alter scientific expectations. Each spacecraft, weighing approximately 721 kilograms, akin to a compact automobile, traveled along distinct paths at varying velocities. On December 15, 1977, a pivotal milestone was reached when Voyager 1 surpassed its twin in distance traveled, owing to its unique trajectory. From that moment, Voyager 1 became a vital instrument in enhancing our understanding of the universe, delivering revelations that have transformed our perception of space. Before exploring its recent groundbreaking discoveries, let's revisit some of Voyager 1's earlier significant achievements. In 1979, when it was approximately 265 million kilometers from Earth, the spacecraft captured high-resolution images of Jupiter. By January of that year, it had completed an impressive 100-hour observation, producing a time-lapse video that showcased Jupiter's rotation. These 3,750 photographs provided unprecedented views of the planet's turbulent atmosphere and intricate patterns. During this mission, Voyager 1 also identified an unseen ring around Jupiter and discovered 2 new moons, greatly enriching our understanding of the planet's complex system. To maintain its course and prevent a collision with Titan, one of Saturn's moons, the spacecraft executed several course adjustments. Subsequently, the mission's focus shifted beyond the solar system's planets as the probe ventured into interstellar space, traveling at an astonishing speed of 325 million kilometers annually. In January 1990, Voyager 1 commenced its mission to examine interstellar space, pushing beyond the outer edges of our solar system. During this phase, it accomplished several exceptional tasks, such as discovering 4 additional moons, Mimas, Enceladus, Tethys, and Rhea, and capturing some of the most iconic images of the solar system's distant regions. On February 14, 1990, from about 6 billion kilometers away from the Sun, Voyager 1 took the famous Family Portrait, a mosaic of photographs depicting the inner planets. This series of 60 images was added to the probe's expansive catalog, which already featured hundreds of photos from encounters with gas giants. Meanwhile, Voyager 2 achieved remarkable milestones on its journey. It recorded wind velocities on Neptune that exceeded 2,100 kilometers per hour, about 1,300 meters per second, the fastest atmospheric winds ever documented in the solar system. It also studied Triton, Neptune's largest moon, where temperatures plummeted to a frigid -391 degrees Fahrenheit, making it one of the coldest known places. Triton exhibited evidence of icy geysers ejecting nitrogen gas and frozen particles up to 5 kilometers high, revealing its dynamic geology. These astonishing discoveries significantly deepened our insight into the diverse and dynamic conditions found at the solar system's outer boundaries. The contributions of Voyager 1 and 2 have been transformative, revealing unexpected activity on moons once believed to be dormant. This prompted a reassessment of earlier theories about their geology. Voyager 2, in particular, made history as the only spacecraft to date to visit both Uranus and Neptune up close, an unmatched achievement. NASA extended the lifespan of these historic missions through clever methods, such as deactivating non-essential systems to conserve energy. The mission is anticipated to last until 2030, marking the end of a remarkable era for the teams who have dedicated their lives to it. The design and engineering of Voyager 1 and 2 were groundbreaking. Built to rotate slowly, they minimized image blur during movement. Even before arriving at the outer planets, the spacecraft began sending back detailed photos of Jupiter, revealing swirling cloud patterns and the massive Great Red Spot, a storm system that has intrigued scientists for decades. One of the most exciting findings was the detection of active volcanoes on Io, one of Jupiter's moons. The spacecraft's instruments detected strange readings, which were later confirmed by images showing giant volcanic plumes and a landscape dramatically reshaped by eruptions. One eruption was found to be 1,000 times more powerful than the Mount St. Helens explosion, covering an area nearly the size of France. As the probes continued their mission, they were gradually powered down to conserve energy for interstellar travel. Interestingly, they didn't capture photos of Mercury or Mars due to technical restrictions. NASA later launched additional landmark missions, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 overtook Pioneer 11 as the most distant probe from Earth. Nonetheless, Voyager 1 continued its journey and, after 14 more years, officially entered interstellar space on August 25, 2012. A major contributor to these missions' triumph was the strategic employment of gravitational slingshot maneuvers, which propelled the spacecraft toward their targets while conserving fuel. Rather than depending entirely on engine power, they harnessed the gravitational pull of planets to accelerate and redirect their paths. This technique enabled them to traverse vast expanses with minimal energy consumption. As Voyager 1 neared Jupiter, the planet's gravity increased the spacecraft's speed. Accurate computations were critical to prevent hazardous deviations in trajectory or velocity. These gravitational boosts allowed the probes to skillfully navigate the solar system. Voyager 2 similarly utilized the gravity of Jupiter and Saturn to reach Uranus and Neptune, further demonstrating the effectiveness of this method. Reflecting on these extraordinary endeavors, researchers are eagerly anticipating more insights from the unusual signals Voyager 1 has recently recorded. The spacecraft persists in exploring the region beyond our solar system, accumulating data from the fringes of giant planets like Jupiter, Saturn, Uranus, and Neptune. Voyager 1's time-lapse photographs documented 10 volcanic eruptions on Jupiter, revealed more moons, and uncovered a previously unknown ring surrounding the planet. These observations significantly enhanced our understanding of the Jovian system. It also discovered 4 additional moons of Saturn: Mimas, Enceladus, Tethys, and Rhea, and transmitted exceptional imagery of the planet and its ring system, offering fresh perspectives on its intricate makeup. The flybys of Uranus and Neptune furnished vital information regarding their atmospheres and satellites, furthering our comprehension of the solar system's distant territories. After finalizing their planetary surveys, the probes set a course for interstellar space, where they continue to collect essential scientific information. This ongoing mission broadens our awareness of what resides beyond our immediate cosmic surroundings. As we await new revelations from Voyager 1's mysterious transmissions and consider their implications for our understanding of the universe, the inspirational voyages of these spacecraft continue to mesmerize both scientists and astronomy enthusiasts around the world. Their contributions remain critical in advancing human knowledge and extending the frontiers of space science. The Voyager expeditions provided us with unmatched views of the solar system and beyond, yielding iconic visuals and groundbreaking scientific findings. Beyond their technical achievements, the spacecraft carry a cultural artifact intended to communicate Earth's story to any intelligent life forms they may encounter. The Golden Record includes greetings in 55 languages, musical selections from around the globe, and natural sounds such as rainfall and whale songs. This interstellar message in a bottle reflects humanity's aspiration that advanced civilizations may one day discover and understand it. Voyager 1 and 2 were outfitted with a comprehensive suite of scientific instruments that revolutionized space research. These tools included magnetic field sensors, plasma wave detectors, and imaging devices, all of which yielded invaluable data about space conditions. The magnetometers elucidated the magnetic fields of the outer planets and their interactions with the surrounding environment. Plasma sensors provided insight into how solar winds affect planetary atmospheres. One of the most pivotal successes of the missions was the mapping of the heliosphere's boundary, a region dominated by solar particles and magnetic forces that envelop our solar system. As Voyager 1 approached this frontier, it observed a shift from solar origin particles to interstellar matter, furnishing vital evidence on how this boundary shields Earth from harmful cosmic radiation. The spacecraft also identified the termination shock, a zone where the solar wind decelerates and becomes denser. Beyond this lies the heliosheath, a chaotic region where solar and interstellar materials collide, forming a rich and dynamic plasma environment. Voyager 2's journey contributed additional clarity to our understanding of these outermost solar regions. Its measurements, especially of Uranus's tilted magnetic field, challenged prior models and inspired fresh exploration into planetary magnetism.